So let's talk about the Google Kubernetes engine in GCP. It consists of creating a cluster, and each cluster consists of the control plane and the nodes. So the node should have a Docker runtime installed in it, and each node corresponds to one virtual machine getting created in the compute engine of GCP. So one more node would correspond to one more compute engine getting created in GCP. And within each node is an entity known as the pod. So here in this diagram I have shown two pods, pod 1 and pod 2, and each of them have two replicas. And each pod basically consists of the containerized app that you have created along with shared volumes in them. And a pod also has an IP address attached to it. Here I have shown two pods with two replicas, and all of them have a separate IP address attached to it. On top of these pods there is another abstraction called as the service. It basically provides a single IP address through which you can access these pods. It can also act as a load balancer in case one of the pod within the replica gets more traffic. Now with this information we can create two configuration files, the deployment YAML file and the service YAML file. The deployment YAML file will consist of all information regarding the pods, the path to the image, and the number of replicas that need to be created for each pod. And the service YAML file will tell you how the IP address for the service resource has to be created, whether it has to be an external IP address or whether it has to be a cluster IP address so that the communication is just within the cluster. Apart from that, there are two other resources in the node layer that Kubernetes has. The first one is the kproxy. The kproxy service is used to implement the service resource in the nodes, whereas the kubelet makes sure that the containers are running properly within a pod. The control plane consists of the API server. This is basically the front end for the Kubernetes control plane, and a user through the kubectl command calls the API server, and this API server forwards the request to the concerned party. The other components that make up the control plane is the etcd. The etcd is basically a distributed key value store, and it consists of all the state changes that have happened in the Kubernetes cluster. So all the state changes are recorded in the etcd. So it is very important that the etcd is always up to date. Then there is the scheduler. The scheduler watches for new pods that get created and assigns nodes to these newly created pods based on resource availability. Then there is the control manager. The job of the control manager is to see the current state of the cluster and to move it towards the desired state if and when necessary. So what that means is, let's assume pod 1 has a desired state of 2 replica, but one of the replicas got deleted. So the control manager makes sure that one new extra replica gets created. So that is the primary job of the control manager. Then there is the cloud control manager. The cloud control manager lets you link your cluster to your cloud provider's API, and it is only mandatory if your cluster is within a cloud provider's infrastructure. So let's create our first Kubernetes cluster in GCP. To do that, you can either search for Kubernetes engine, or you can go to the hamburger menu, Kubernetes engine, and you can click on clusters. So here you'll get the first step to configure your cluster. You need to give your name. Then you need to choose whether you want it to be a regional or a zonal resource. If you make it as regional, then your control plane and your node plane would be replicated across multiple regions. So for high availability, it's preferable to choose regional over zonal. But for the sake of this particular demo, I'll make it as zonal. The next thing I can choose is I can click on the default pool and I can choose the number of nodes I wish here. So I will keep it as 2. And if you click on the nodes, you can see which particular machine configuration you wish. So I will let this remain as E2. So I get 4 GB memory and I get 1 shared core. The other important thing is you can go to your networking tab and you can choose here whether you want your cluster to be a public cluster or a private cluster. So if you click on private cluster, then there is no public IP address, and by default the control plane would be inaccessible. So I will leave this as a public cluster. Then here you have to choose which particular VPC you want your cluster to be in. So I will choose my first VPC and the subnet would be US Central 1. And here you can decide how many pods you want to run in each node. So by default it is 110. I will leave it as it is. So that's it. Let me just click on create. So once I click create, I will create a zonal resource with two nodes with two nodes created in US Central 1. So let me just click on create. So my cluster has been created. So the next thing I need to do is I need to create my deployment.yaml file. So to do that, you can just go to your workloads and click on deploy. So this UI is basically an easier way of creating the YAML file. So I will click on new container image. So I have a normal Express application just that returns just a hello world back to the user. So let me just show you that particular application. So it's just a hello world application that is just created. So I will choose my repo. So it will be a GitHub repo, and this is my repository, and then I will just give this as, so I don't need to give anything here. So I will just click on continue, and here I need to give the name of my application. So I'll give it as Express app, and this label is important. So each pod is identified by a label, and that label is basically the key value pair you give here. So the pod would be identified by this particular value, Express app. So this is the YAML that gets created. So this is basically the deployment YAML. So it has a kind of deployment, and these are the specs for that particular YAML file. So it will create 3 replicas, and the name of the pod would be Express app, and it's getting the image from this particular image. And again, this is the name of the container. And it also has a horizontal pod autoscaler that gets automatically created. So it will have a minimum replica of 1, maximum of 5. And so these replicas correspond to the number of pods that will be created. So basically this will create 3 pods. And the maximum number of pod would be, minimum would be 1, the maximum would be 5. And it would basically scale based on the CPU utilization. So let me close this and deploy. So the container image has been built. Now it's deploying. So as you can see that there are 3 nodes that have been created. So now that we have configured the deployment.yaml and deployed it, so the next thing we need to do is we need to create a service YAML file so that we are able to access these nodes. So to do that, what we'll do is we will go to actions and click on expose. Here I need to give what kind of service type I require. So if I give cluster IP as the service type, then it cannot access. So nobody from outside the cluster can access this particular service. So what I will do is I'll create it as a load balancer, and it will create an external IP through which I can access it. The port would be 80, and the target port would be 8080 because my node application is basically running on port 8080. So if I go back to my Express app, you can see that it's 8080. So what it will do is this particular service would read the 8080 port, and then it would map it to the 80 port of the external IP address. So let me just click on expose. So now my service has been created, and it has created an external endpoint. So let me just open this endpoint. So if I click on this, you can see that the particular Express application has been deployed. So let's have a look at all the configurations that we have done. So we have created a cluster with 2 nodes and 8 GB of memory. So if I click on this cluster, and if I go to the bottom, and if I click on the default pool, then here I can see the 2 nodes that I have created. Now these 2 nodes can also be seen if you go to the virtual machine. So go to your VM instances. You can see those 2 nodes here as well. So what that means is that for each node corresponds to 1 virtual machine instance. So let's go to the workloads. So the workload basically defines how your deployment.yaml file is configured. So let me click on this. So you can go to the actions and see all the configurations that you can do. So if you click on auto scale, it will show you the minimum and the maximum replicas that can be created based on CPU utilization. So currently the minimum replica is 2 and the maximum is 5, and it will auto scale based on 80% CPU utilization. So currently, because there isn't much usage, so it has 2 pods created. The expose is basically to create the service.yaml file, and the scale is basically if you want to scale up your pod without any auto scaling. So if I update this to 3, then a new pod will be created. And if I refresh this, you can see that one extra pod got created here. And the last thing we'll do is we'll create a CI/CD pipeline. So to do that, you can click on automated deployment. Here you can choose your repository. I think click on continue. You have to choose your branch, so it will be main, and the name of the Docker file would be Docker file. And the next part is the important one. So what you need to do is you need to copy this YAML file that Google generates for you. So this YAML file is basically a concatenation of your deployment YAML and your service YAML. So what I'll do is I'll just copy this and I'll paste it in my Git repo. And so once I've committed my changes, I have to give the path to that particular YAML file. So I've created a file called deployment.yaml. So I'll just update this once. And once that is done, any new change that has happened in the Git will be reflected in this particular, in the output as well. So let's just wait for that. So what I have done is, in the index.js file, I have changed the wordings from version 4 to version 5. So hopefully in the UI, the next time I log into this application, I should be seeing version 5 instead of version 4. So let's just wait for that to happen. So you can see that it has changed to version 5.